So part 9 talks about relational database, where we'll talk about SQL and how we use SQL to create the data that is in the database, and then to apply the data manipulations, the CURD operations. So we'll study from the chapters of Punaya, Raj Punaya, and also through the notebooks. So to understand this relational database, I need to talk about SQL. SQL is nothing but a structured query language. So it's a language, most like a programming language, that helps us to create the data in the database and to retrieve the data and to update the data. So there are two main components of SQL. Let me put this on recording. Okay. So there are two main components of SQL, which is data definition language, as you see on the screen, and data manipulation language, okay, with respect to SQL. So data definition is used to define the database structure, implement the database structure and constraints of the relational data model. Anything you want to define, you want to create a database, we use the data definition language, where you can create a database, you can define, you're creating in the sense you can define the database, you can apply the constraints in the database, create a relationship between the tables, between the relations. Then data manipulation language is used for the operations, the create, retrieve, update, delete operations, implementing the operation in the relational data model. So these are two main components of SQL, structured query language, which is used to play with the data. Fine. So SQL is a declarative language, which means it specifies what should be accomplished. Okay, it's not like in other programming languages. Those are imperative languages, which means how to accomplish the task or how to accomplish a job. Right. So SQL is a declarative language. Example of SQL, for example, I want to display all the records of the patients from the patient relation or from the patient table. I can say select a star from patient. So here select star from patient. So we can easily understand here is that it is a command to select something. Okay, so select star. Star is an operator here that select all the records from patient. So patient is a relation here, or it's a table name. So this will retrieve all the records of the patient table or the relation, okay, and give it as an output to this query. We call this as a SQL query, where the SQL it will be displaying all the records of the patient. So let's look at these exercises for this select. We do have an exercise from 9.1 to 9.3, which will give us more on this. Sorry. Fine. So we have a first thing is to create the tables, right, in a data using data definition language. Fine. So I said there are two main components of the SQL, which is data manipulation language, data definition language, and then data manipulation language. So in defining the data is nothing but creating the tables in the database. Okay. Now we did discuss about this in the part 8 about this list of patients and the doctors, assigned doctors, fine, or a list of doctors and their patient. So we can create a relation, create tables by using a command called create table. Create table, then we give the table name, and then we record it. So we came to know that we have two relations here. One is patient relation and one is doctor relation that we discuss in part 8. that patient relation has a relationship with the doctor relation, including a primary key doctor ID from the doctor table or a doctor relation. There's a relation and table, both are same. Okay. So here patient ID, patient name is the patient ID is a primary key and doctor ID is a primary key. So why it is primary key? Because these are unique in the table. Okay. So each top table or each tuple or a row of a patient relation, that is patient table, represent a particular patient who is identified by a particular patient ID. So patient ID is used to refer to a particular patient. So hence patient ID will be the primary key. Similarly, doctor ID will be the primary key. Hence, because doctor ID will be used to represent or to identify any doctor. So in that case, doctor ID will be the primary key. So when we are taking this a key from one table into another table, so there becomes that key as a as a foreign key. Okay, so that is defined as a relation that a doctor may be responsible for no or one or more patient, and this is represented by a foreign key column called doctor ID in the patient relation, recording the primary key of the related doctor row. So this creates a relationship between the doctor and the patient. So hence we have created this patient. So how do we create this in a database? Is that we use a create table key statement or a command, create table, then the name of the table. So patient is the name of the table. If you want to create a student table, you can say create table student. So create table patient. Then we have patient ID and patient name, right? So patient ID. So we give patient ID, and then we specify what type of data it will take. So we say patient ID char 4. It means that it will take a characters with four digits or 4 characters. And then patient name varchar 20 variable character. So here 4 characters, in the sense it will take only 4 characters. Okay, patient ID will be only 4 characters, not 5, not 6, maximum 4 characters. And patient name varchar 20, it is a variable length character. So here patient name can be any length. Okay, we specify 20 to say, okay, it maximum you can keep up to 20, but if it exceeds 20, it's okay. Okay, then we have a doctor ID in the patient relation char 3, third character. I mean, it will be of 3 characters. Doctor ID will be. Then we specify the primary key and the foreign key. So in this, for this table, the primary key will be the patient ID. So we say primary key patient ID and foreign key doctor ID. But from which table it is referred? So we say references doctor of doctor ID. So it means that it will be referred to a doctor relation and the doctor ID of the doctor relation. Okay. So in that sense, this whole table will be created, that it will have a patient ID and that will be a primary key. It will have patient name. Then it will have a doctor ID that will be a foreign key referring to the doctor ID in the doctor table with this reference. Then we can create a create table doctor as like patient. We can create doctor ID as 3 characters, doctor name varchar 20, and the primary key is doctor ID. So by executing these 2 statements, definitely these 2 statements will create the 2 tables, patient and doctor. Okay. Suppose that you want to add more information in the table.
Doctor,
Yes.
sorry, I have a question in the previous page.
This page. Yes.
Yes, in patient ID char 4 and patient name and patient doctor ID 3 and 20. This it's mean the limit the limit.
Limits, yes, the limit. A patient ID will take 4 characters only. Okay. When we say char 4, when we say varchar 20, so it is a variable length characters. Variable length in the sense it can be 20, it can be more than 20.
Okay, varchar char.
Yeah, varchar, it means variable length. It will be in variable length.
Okay, another question, Doctor. If I want to run this code, On what application?
You can run on the notebooks. You have the notebooks of part 9. You can run on the notebooks. I'll show you, inshallah.
Okay.
You can also use any other DBMS package. You can use any other, like you can use MySQL if you have to run this to create it. You can run on any different DBMS. But here we use notebooks. So in part 9 of the notebooks, there exist. Yani, I will show you that, inshallah. Clear. So now if you want to add more, it's very simple. You can add more data, right? So in the create table, you just revise it to add patient date of birth, gender, height, weight, okay, all other data, fine. We can also enforce the constraints. For example, patient ID takes a value between P000 and P99. So it means that P and then 3 digits, okay? And then patient name will always have a value. So patient name cannot be null. Date of birth will always have a value. So it means date of birth cannot be null. Gender will take a value either F or M. And the height and weight should be either null or greater than 0. Cannot be 0. Height and weight cannot be 0. Okay. So in that sense, we are enforcing these constraints, rules on this table. Okay, so how do we enforce that? We have to enforce it by uniqueness, okay, and by not null, for example. So I'll just take you to the notebook where I can explain that. I'm trying to upload a notebook of data definition language. I'll take the solution notebook. You can go to the 9.1 and do the solution later. So if I want to do that, so upload it, solution. Can you see the screen? Notebook?
No, the screen is not clear.
Okay. Now you can see the notebook, right? So I have uploaded this notebook. Let me just shut down and delete this notebook and upload it again. I'm taking this notebook 9.1, okay, solution notebook. And where is this? 9.1. Yeah, uploaded. Okay. So this solution notebook of 9.1, you also have that notebook in 9.1. You can just upload that also and do by yourself after this session. Okay. DDL, fine. So here there are some queries for you that you do, fine. Here some activities. Okay, simple activities. You can do that. Now here you can see that, okay, we are running this, right, to create an SQL load extension, SQL extension, fine, to run the SQLs. So we run it. Just a second. Assalamu alaikum, sir. Okay, now here we're just creating a database. So we can see that those constraints are enforced here. So we use here a drop table if exist patient. A cascade is a feature of deleting the reference table. So drop table is for deleting the table. So drop table if exist, okay, the patient table if there exist, just because we are creating a new table. So we create a table patient, where we say create table patient, then you open a bracket and say patient ID char for not null. So not null is a constraint here, meaning that patient ID cannot be null. When you insert the data into this table, when you enter the data, you have to enter the ID. There should be an ID. And also we write a constraint check patient ID similar to this expression. What is this expression says? P, then any number from 0 to 9, then any number from 0 to 9, then any number from 0 to 9. So it will be 3 digits. P, digit 1, 2, 3. So check that patient ID will be similar to this always. So if you're not entering similar to this, then the data will not be taken. So meaning that patient ID not null, cannot take a null value, and check patient ID is similar to this format. So this is enforcing a constraint here, enforcing a rule that patient ID cannot be null and patient ID should be P and 3 digits. Then patient name varchar 20 not null. So this is also enforcing a constraint that patient ID cannot be null. Then date of birth, date not null. So date is a type here, like varchar date is a type that will give for a date, and it cannot be null. Gender character not null, and check gender is F or gender is equal to M. So it can take F or M. This is also enforced here. Height decimal 4,1. So it is a decimal value from 4 digits 0.1, and then height should be greater than 0. Check decimal weight should be this a decimal value, and check that weight is greater than 1. Primary key is patient ID. Okay, now here we are inserting the data. Insert into patient ID, patient name, date of birth, gender, height, weight, and values. These are the values. Patient ID is P001, name, date of birth, gender, height, and weight. Similarly, insert into patient another record, insert into patient another record, and so on. Right. So as you write here the attributes, you write its values. So if you execute this, you will see that all these records, one row is affected. For every one insert, one row is affected. So all done, all the data has been inserted. So if you want to see that, we say select star from patient, order by patient ID. So you can just remove this order by for now, and just we want to see just a patient data without any order. So you can see patient ID, patient name, date of birth, gender, height, weight, as you have inserted. Okay, it is been inserted here. So what is that order by then? Order by patient ID. Order by is just like arranging the data. Okay, order by patient ID. So in ascending order of patient ID, all the data will be appearing. So you can also say order by patient name, order by date of birth, order by gender, order by height, order by weight. You can also do that. So this is enforcing all the constraints, like what we said, the constraints are enforced here. Okay, all these constraints are enforced here. Okay, uniqueness constraint, primary key should be unique. Fine, we can also add that uniqueness constraint here. If whenever we see primary key should be unique, so you can also check here, for example, patient ID CAG4 not null, can also say unique, or if you make patient ID as primary key, by default it will be unique. So it will not take repeated value. No patient will have same ID. So that's about creating the table or creating the data, fine, in the database. So this is what we are just looking here in this data definition language, that we create the data in data definition language, we create the data and we enforce the constraints, and we create a relationship between the data. Right. Although in our example of notebook here, we are not creating any relationship there because we did not create the doctor table. So hence we are not creating any relationship and there is no foreign key in the patient table. So it's just give an example of the data definition language. Then we have a data manipulation language. So data manipulation language, so it is for applying these the CRUD operation, create, retrieve, update, and delete the data. Okay, so we can insert the data. We saw how we insert the data. We can update the data. We can delete the data. Okay, or we can retrieve the data by using select statement. So the general form of the select statement is this: select distinct. Whatever we see in this bracket, square brackets, it is optional. Okay, select distinct star, or you can say distinct of star. So distinct is optional here. Star, or you can also say column list. Let's say I don't want to select all the data. I want just one patient ID and their names. So that will be only a select with patient ID and name. So let's say here I will say, I will not say star, I will say just patient ID, comma, patient name. So select patient ID, patient name from patient, order by ID. I'll run this. So I'll get patient ID and name. So either you say star or you define the columns that what you want. Star means all columns, column list you define from table list. So he can add only one table, or you can have more than one table. If you are selecting the data from more than one table, you can have this table list here separated by comma. Where condition, you can also specify the condition here, that on what condition you want to select the data. Let's say, for example, where patient ID is P001. You can specify that here. Then group by column. Okay, you can also group the data in groups. Having condition, if you want to apply the condition on the groups, you can apply the having conditions. Order by, you have seen, if you want to list is order in ascending or descending order. And then limit, you can also limit the number of rows. You don't want to list 100 rows or all the data. You just want to limit to 10 records, 15 records. You can specify in the limits. Okay. So this is all you can see from 9.4 to 9.6 exercises here. I just discussed with you 9.4 up to 5. Here you can see select column list from table. So whenever you want to select some columns from a table, I just gave you an example here. Select patient ID, patient name from patient. Okay. So let's say, for example, check patient name and gender from patient will list you the patient ID. Then if you want to select the distinct of patient names, so here you can see, for example, sometimes a patient may have two patients may have same names, similar name. So the names will be repeated here. So if you want to remove those repeated names, right, we use a distinct keyword here. So select distinct of patient name, comma gender from patient. So distinct in the sense the repeated values will be removed. Only one it will appear only once. Okay. So in this record you can see that it's given that Harris M is repeated. Harris M. It is repeated. Okay. So it might be these are two patients. Fine. But we don't want to see the repeated values and we just want the single values. Then we can say distinct. So distinct will remove the patient. Okay, now we can also see select it based on some conditions. So select all the female patients, for example, whose gender is F. We can do that, right? So it is by using the where clause. Okay, so I'll add a where clause here. Where gender equals F. So what does it will do? It will select all the patients whose gender is F. It means it will select only the female patients. If you want to see that gender also here, you can just say gender here. Select patient ID, patient name, gender from patient where gender equals F. So you can see only gender F patients, the female patients are selected. So where clause can be used if you want to limit it by some condition. You want to limit that by some conditions. So views we will discuss here. Views in part 23 we'll be discussing more on views. Okay, let me go back here to the select. Okay, this is what the select is all about. Select is the SQL operation is always a closed operation. Okay, closed operation in the sense the output of the SQL query will be again a table. So the input will be tables and the output will be again a table in a form of table. So that you can see here, the results are in a form of table. So what you have created is a table, and what you query and you get the result is again the in a form of table. So that's why it is called closed operations. Okay, the order of the SQL processing. When we write this statement, select patient ID, patient name, gender from patient, where, and order by, in what order this will be executed inside the system. So the order is this. First, the from clause will be executed, then the where clause will be applied, then if there is a group by will be applied, then having will be applied, then select will be applied, then order by B will be done, and then limits will be applied. So this is the order by which the SQL statement will be executed. So for example, I have this statement, select patient ID from patient where gender equals F. So first from will be executed from patient. It means it will take the whole patient table. Then where will be applied. Then it will filter only female patients. Then select will be applied. Then it will take patient ID, name, gender only. Okay. And then order by will be applied. So in that order, this will be executed. Okay. So you need to be see this order here. Coping with missing values, we said that we are using null here as a marker to deal with the missing values. So we can use this null to see where is the missing values. So for example, we say if we want to know the patient whose weight is not entered, okay, then it is a null there. Then we say select star from patient where weight is null, where weight is null. So we can apply that here. Select, we'll just say, so okay, for example, select star from patient where weight is null. Okay, order by, keep it, let's keep it order by. So you can see that yes, we have weight none for 2 patients. Okay, so weight is not been entered here. So this is null. So is null, is not null. We can also use is not null to check that it does not, it has some value. Okay, so I will say is not null, meaning that I get all those patient whose data has been entered. Okay, so we can use this null in where clause or in having clause to see the missing values or to see that which data has in null values. Okay, aggregation, we can use aggregate functions here in the select. For example, we want to count the number of patients, we want to count the number of heights, want to find the minimum and maximum, average. Okay, all these aggregate functions that we discuss about these aggregate functions in our, I think, in our analysis part of the data analysis pipeline. So that we can also apply here using SQL. So SQL provides us a lot of aggregate functions like count, minimum, maximum, average, okay, other functions. So that those aggregate functions you can apply in the select. Fine. Count of star, count of distinct. What is the difference between count of star, count of distinct of patient name? So here count of star will count all the patients, okay, whether there is a repeated names of the patient or not. But distinct of patient name will count only the patient who, without repeating their name. So if there are 2 patients having the same name, it will be counted as only one. If there are 3 patients having the same name, it will be counted as only one because of the distinct. Okay. So you can see the result of this. Total patient is 17. Distinct of patient name is 15, meaning that there are 2 patients having the same name as other patient. So those 2 will be counted as only once. Okay. Then count of height is 15. Count of minimum of weight, minimum of height and weight, maximum of weight, average of weight is given here. Okay. all this data. You can see this is again the result of this query is again in a form of table. So that's about the aggregate function. So you can use aggregate functions in the SQL if you want. Then we have the topic here called views. Views are nothing but temporary tables. Okay, so a view may be used in SQL statement where table is expected. For example, on the from clause of a select statement, we can create views here. For example, create view of female patient as select star from patient where gender equals F. So this will create a temporary table called female patients where for all the patients or all the female patients. Okay, this with this executing this query. Then you can also apply some rule, the same you can apply here on female patients. But this will be a temporary table. If you update this table, patient will not affect this female patient table. And then you can also create a materialized view. Materialized view in the sense you can also refresh that view to get the new added data in the parent table. So if we create a materialized view, for example, you said create materialized view instead of create view. You have a create view, you have create materialized view. When you say materialized view, then when you update the table, you can call a refresh materialized view to update the view also. So I'm creating here female patient table by this query. So whatever the female patients are there, a view will be created. A separate view table will be created for this. So if I create materialized view, then this female patient, whenever I add any new female patient to the patient table, by refreshing this view, I can, that the new patients will also be added here by refreshing this. If you are creating materialized view. So how you refresh that? You just pass the query refresh materialized view to refresh that view to get the new data which is added. So this is all what you have here for you in part number 9. So please go through these exercises and activities. Very simple and easy, and you can practice this. You can do this on the notebook of part 9. So there are a number of notebooks of part 9. I think there are 2 notebooks for part 9. Let me just quickly take those notebooks here. Yeah, I have the 2 notebooks, DDL and DML, and views, 3 notebooks. Okay, so solution notebooks are given here. So please go through this and execute and write your own queries. So for example, here you have an activities like execute the data manipulation statement, register the details of new patient whose name is Kramer, who born on 1st of November, has been assigned to the patient ID of P098. So you execute this. So insert into patient with patient ID, name, date of birth, gender, and these are the values. And then you can select the data. Fine. So you can also update the patients if you want to change the data of the patients. P is in 98 to new data. Fine. You can also delete the patient. Delete from patient where patient ID is P098. So this will delete the record which is added here. And also applying the constraints here. You can check the constraints. Okay. So please do these activities. Okay. And this will help you to gain the practical knowledge on SQL, okay, basic of SQL. So we'll stop here for today. And if you have any questions, please go ahead.